A very good morning to everyone and Dr. Rolizawati. My name is Chawinja, and in this video, our group will be presenting on our project 1, and these are my group mates, Tan Jiming, Elijah, and also Ng Hin. We have chosen a student's attendance management system as our topic, as attendance tracking is the core requirement in universities and schools. But look at the primary school and secondary school, some of them still rely on traditional methods like using paper sheets, which is very slow, prone to errors, and also make it difficult to retrieve past attendance record. So to solve these issues, our project focuses on building the back-end database only for a digitalized attendance system. The goal is to create a centralized and well-structured database that can store, manage all the important entities like students, lecturers, sessions, and also their attendance records. Now we proceed to our main objectives of our project, including designing stable SQL table structures using the DDL, managing data using DML, and also retrieving information through advanced SQL queries. And we also ensure data accuracy and also consistency using these constraints. And finally, the system is optimized with indexing so that it can later be integrated with any front-end application in the real-world use. Now I will proceed to the DDL part. We begin by creating our main database called Attendance System DB. Next, we design 6 tables, which is students, lecturers, courses, enrollments, sessions, and also attendance record. Each table was structured with appropriate data types and also constraints. For example, the students table include a primary key for student ID, not null fields to prevent missing information, and also the check constraint to validate data such as enrollment year. Following by the lecturers table, we use unique constraints to ensure that each lecturer email is not duplicated, and the course table includes check constraints to validate credit hours, ensuring the system only stores for valid values. Next, we also implemented the enrollments and attendance records table using primary and foreign keys to maintain strong relationship between the students, courses, and also attendance session table, and this ensures the database always maintains the referential integrity. Lastly, I've created a temporary cost table here to show the usage of drop table. And in addition, we also demonstrate the auto table by modifying column data types and also adding new attributes. So that's all from me.
For this system, we first insert sample data into 4 tables. Lecturers table, we insert first name, last name, email, and department for each lecturer. For courses, we insert course ID, course name, credits, semester, section, and the lecturer in charge. For students table, we insert student ID, name, phone, enrollment year, status, and email. And for the enrollments, this table links student to course with the enrollment date and the status. For example, enroll. So the pattern is the same. Insert into table name and its column. Values by the values we want to insert in. Each line add one new row into the table. Next, we insert data for class sessions and attendance. For the sessions table, we store when each class happened using course ID and the session date and time. For attendance record table, it links the student to a specific session and records the status such as present, absent, late, or excused. Again, we use insert into to populate above table, so later we can query who attend which class and when. Update is used to modify existing row. The first example, set student status to inactive if their enrollment year is 2021 or earlier. The second example, change an enrollment status to drop for specific student and course. The third example show update a lecturer's email address. The important part is the where clause, which target which row to update. Without where, we will update every row in the table. Next, the delete is used to remove rows. The first, delete attendance record where the status is excused. Next, remove one specific session of a course based on course ID and date. And the last is remove one student's enrollment for a particular course. Same idea here. Delete from table name where condition. We will use where to avoid deleting all data by mistake. So in summary, DML in this project show how we insert initial data, update it when something changed, and delete record when we no longer need. Next is data retrieval, or DQL using select. In the first query, we filter students. We select student ID, name and enrollment years. We use where enrollment year between 2021 and 2024, and status equal to active. So only active student in that year range appear in the output. For the courses, we show how to search by keyword, where course name like Bahasa or course name like Pemasaran. The percent will correct means as long as the name contains the word Bahasa or Pemasaran, it will be returned. This example focuses on sorting and limiting results. We select course ID, course name, and credits from courses, then order by credits, descending sort courses from highest to lowest credit. Limit 5 means that we only show the top 5 rows, so the output show the 5 courses with the highest credits. Then we use aggregate functions. The first query, count star symbol on students to get total number of students. Second, on courses, we use average credits, max credit, and mean credits to see the average, highest, and lowest course credit. And the last query, we join enrollments with courses, then sum credits and group by e.student ID. This calculates the total credits taken by each student. So with select, plus filtering, sorting, and aggregation, we can answer most questions about our data.
For the group by, we created two queries. The first query groups session by course ID and counts how many sessions have each course has. And we use having to filter courses with two or more sessions. The second query groups attendance records by the student to show how many times each student has attended. And having is used to show only students who have at least one presence. For numeric and string functions, we demonstrated these several formatting functions. So concat and upper is used to generate uppercase full names, and substr is used to take the first three letters of a name, and round and truncate to format credit calculations. And these functions are useful when preparing data for display in an interface. So for conditional logic, we use case when to classify each student's attendance performance. So the query counts present, late, and absent records, and then categorizes the student as good, poor, or average attendance based on the percentage of presence. And this allows the system to automatically evaluate the attendance quality. We also implemented all three types of the subquery. So for the first one is the single row subquery. So the single row subquery finds the students who enrolled on the earliest date. We also implemented a multi-role subquery that returns lecturers that for teaching courses with more than one session. Finally, a correlated subquery is used to identify students whose present count is above the overall average, and these subqueries demonstrate how it can provide layered and intelligent filtering. For set operations, we use union to combine student and lecturer names into one unified list. And not exist is also used to detect students who are enrolled but have no attendance records. So this is very useful for spotting missing data. Finally, we also implemented four join types. So natural join automatically matches same name columns, such as student ID. And inner join is used to retrieve detailed enrollment information by linking students, enrollments, and courses. And we also implemented left outer join to show all courses together with their enrollment counts, even if the count is 0. And self-join compares students with themselves to find pairs from the same enrollment year.
Hello, I'm Elijah, and we'll talk about the indexing and optimization bit3 index. With the index, the bit3 index is the searching row is 1, but without index is just 9 row. So it means that if with the bit3 index is more faster. The example that we use is enrollment that. Yeah, pass next. All right, for this full text index, the example we use is name searching. The name we search is Aisha. This one is the query code. Without index is searching 10 row. With the index is searching 1 row. Means with the full text index is much more faster. All right, for this one, I make a table for comparisons between the bit3 index and full text index. And this one is the possible key, and the row estimated is already displayed this page. All right. For the conclusions, I will say that we make this digital attendance system to replace the traditional paper test method. We're using the DDL, DML, and DQL, and using another index like bit3 and full text index. From this project, we learn about how to improve our SQL skill and collaborate across different back-end tasks.
Now we will proceed to our teamwork conclusion. I took the lead by choosing our topic and brainstorming the tables needed to ensure the system could run smoothly. And we also had a short discussion here to confirm everything before we start. I drafted the introduction to make sure everyone understood the system purpose and also objective before they start their parts. And the main challenge I face here is dividing tasks fairly, since some parts like DQL were more complex than DDL I do. And I have to review my teammates' work after they done their part so that I could learn beyond the DDL section. So if XQL Workbench supported the collaborative editing, it would have been easier for us to work together.
In this project, I handled the DML task by inserting and preparing all required data from the database. I also worked on key DQL queries, such as retrieving active student and filtering enrollment by specific periods. Additionally, I reviewed the outputs to ensure the data and queries were accurate and consistent. For challenge I faced is machine or team database calls was difficult because we have no version control tool to detect conflicts or ensure the safe integration. So, what the solution is, use a proper version control workflow and enforce a consistent schema to avoid much conflict in the future.
For my role in the team, I focused on the advanced DQL operations. I made sure that all retrieved data was accurate, consistent, and aligned with the project requirements. Throughout the process, I worked with multiple types of join, experimented with set operation like union and not exist, and learned how conditional logic such as case when can be applied directly inside the SQL queries to produce meaningful results. One of the challenges I faced was queries returning no results, and this happened mainly due to mismatched keys or missing data. From this, I learned the importance of verifying data, consistency, and checking relationship before writing complex queries. My suggestion for future project is to always test the dataset first to avoid unexpected empty outputs.
All right, for the teamwork conclusion, I would say that I learned how to develop the B-tree index and full text index and learn more how to solve the data efficiently. Although I faced a lot of the challenge, also we discussed and solve the problem more faster. That's it for us. Thank you.